Okay, so welcome all to this webinar of TG88 Smart Cities. I welcome all you on behalf of Chris Bremer from TNO and me, Mia Raksinen from VTT. We are co-chairing this TG88 on smart cities. The objective of this task group is to complete the CIB's vision and perspectives of the future cities, and especially on the expected development of the new technologies on energy, virtual services, urban transport, and living opportunities. And in addition to that, so this task group aims to create a roadmap for the building and construction-related research needs and envisions future smart cities. Just to once more give the big picture about the sustainability and cities. So we have the society part, people and governance. Then we have the environment part, meaning natural and built environment, and then of course the sustainability in the economy-wise, meaning that we need to have a value-driven business and seamless services. And of course, our aim here is to do that in a smart and efficient way to improve the sustainability. So meaning using intelligent and smart urban ecosystems. Just to give you a quick list of the members, so we are roughly around 25 members here in this DG, and the number of this is increasing all the time, which is of course very nice for us and shows the interest of our members. We have had the first meeting in February, end of February. That was the kickoff meeting in Helsinki in Finland, where we started the roadmap process. Now we are in the WebEx meeting, which is the outlook of smart cities, and in the September we will have the second task group meeting, kindly hosted by the NIST, National Institute of Standards and Technology in Washington. And after our workshop, so there will be also Eco District Summit after that. And then in the March we are aiming the third task group meeting, which we are confirming the date then later. Our agenda today is that our first speaker is Director Dr. Chris Jer from NIST, and he will give us the perspective of smart cities in North America. Then we have the Doctor and Director Gillian Hobbs from BRI in UK, and he is giving us the insights from smart cities in Europe. And as a third presentation, we have Professor Stephen Gendall from Ball State University giving us the presentation of open building implementation in smart cities. And the conclusions are given by Business Line Manager Chris Bremer from TNO. Before we start the presentation, so I'll just give you a short introduction about our last meeting in Helsinki, which was the kickoff meeting. So that was the setting priorities and defining the actions in the first kickoff meeting. So what we did, so we divided it to different groups, and we tried to find the prioritized areas. And as you can see here in this picture, so we quite often found that buildings are the key ones, transport is one of the key, energy was seen quite many pictures. So we found common prioritization areas there. And then we did the analysis for those frameworks, so what are the problems, reasons for the problems, and the possible solutions and possible visions. So here you see, for example, energy and buildings. Similar first drafts were done to infrastructures and resource and waste, and for the other topic areas. We are defining those then in the next roadmap, then even clearer and more detail, especially on the technology side. And then last in our meeting, so we also made the first idea of the thematic vision in each area. So what would be the change? What are the actors for the change, and what are the possible obstacles? So that was also our goal, and we are then of course defining this vision sharper in our next DG meeting. So that was quickly what we have done in the previous meeting, and now it's my pleasure to give the floor to Director Dr. Chris Green from NIST, and he will give us the perspective of smart cities in North America. Welcome, Chris.
Thank you, Nemo. Let me go ahead and share my desktop. There. Well, good morning, good afternoon, or good evening, depending on where you're at today. It's a pleasure to join you and to participate in this task group as well. And we're looking forward to an opportunity to meet with all of you again in September. So looking forward to that. I want to talk a little bit about some of the smart cities efforts we're undertaking here at the National Institute of Standards and Technology. In particular, I want to start with something called the Smart America Challenge. And this was a project undertaken by Soko Ri and Jeff Mulligan, who are Presidential Innovation Fellows. And this is a program that brings entrepreneurs from the private sector into government for a year to bring in fresh new ideas, start new directions, get new momentum, and they have certainly done that with the Smart America Challenge. It's really quite an interesting effort. It's a voluntary effort, so let me tell you a little bit about that. The motivation for this is indicated here on this vision slide. Cyber physical systems is a term we use for hybrid engineered and IT systems. So an autonomous vehicle could be a cyber physical system, or a smart grid and a network system, and so on, all count as examples of cyber physical systems. But today, one of the challenges is that these smart systems are often implemented one by one, and so a city might implement a water management system and simultaneously a smart grid or an energy management system, but those two systems typically don't talk to one another and don't interact. And so although water systems are a major consumer of energy, those two systems wouldn't interact. And so what we wanted to do is demonstrate the value of being able to connect cyber physical systems of different types in order to create new capabilities. So that was the motivation. The challenge that we issued was not just to demonstrate technologies for the sake of technologies, but rather to demonstrate that this implementation of interoperable systems makes a real difference, that it can drive job creation, economic growth, new businesses, and it can improve the quality of life and even save lives. So those were the criteria for success that we asked the teams to step up to. And I'll show you a few examples, but they were remarkably capable in doing that, with one of the teams, for example, creating a whole new manufacturing business here in the United States with a large number of new employees, new jobs, and interesting growth. So that was the challenge that we issued. Yeah, in the end, we had more than 100 organizations that organized themselves into 24 teams to participate in the challenge. We launched this in the last December, and we just a week ago had an expo to highlight the outcomes. And participants came from industry. You can see a large number of companies that participated in this challenge. I'll show you some examples in a moment. A number of universities and research institutions from across the country were participating as well. And we had good participation from a variety of agencies at different levels. So the U.S. Department of Transportation, the Department of Defense, Department of Homeland Security, Health and Human Services, and we even had a county government, Montgomery County in Maryland, in the state of Maryland, was also a remarkably capable participant in a public safety challenge, and were an interesting part of this process. So we had these 24 teams. Here's some examples of the areas in which they were participating. And this ranged, from healthcare and energy through autonomous vehicles and smart rooftop installations. And so I think the point that this makes is that smart cities arise from a wide variety of different types of applications and infrastructures. And so creating a truly smart city is about creating a wide variety of systems that enable city operations and improve the quality of life. And it's not limited to any one specific area. And so I think a big advantage in this challenge was opening it up to all possibilities, and we really got a really interesting range of responses. So here are some of the examples. This was an effort put together by AT&T and IBM centered on an energy application for transactive energy. And transactive energy is an emerging approach that uses market forces to match supply and demand for more agile and responsive electric grids. So this provides greater options for consumers and it enables more efficient management for suppliers. So IBM and AT&T are developing a transactive energy management platform that can manage diverse devices, systems, and control signals along the supply chain and create a market-driven grid system. So IBM in this case provides the computational platform, and AT&T provides the machine-to-machine services, smart grid device connection points, and a data platform. And so the overall goal here is to use market-driven mechanisms to save energy, increase reliability, reduce outages, and give customers options for controlling their own energy and energy resources. In another example, this was a large number of organizations that came together to create systems for disaster response or emergency response. So this program, SERS, or Smart Energy Response System, integrates a range of cyber-physical systems from autonomous aircraft to agile robots, sensored search dogs, disaster area ad hoc networks, and rescue animals and first responder teams. And the idea is to provide quick response capabilities, comprehensive awareness, and effective resource applications to save lives and speed recovery for the full spectrum of disaster scenarios. A large number of teams, participants were from the University of Washington, from Blue Haptics, this is a telerobotics company, National Instruments for robot systems and software, MathWorks for dispatch system, Boeing provided drones, aerial drones, MIT Media Lab and the University of North Texas provided communications network systems, and the University of North Carolina had instrumented search and rescue dogs, with Worcester Polytechnic providing humanoid robots. So this was a really broad effort creating capable disaster response systems. Here's another example that was a joint effort of Honda and Qualcomm. And in the U.S., we have the positive development that the number of traffic fatalities is going down over time. But unfortunately, the number of incidents involving pedestrians is going up. And so in the area of intelligent vehicles, this is an effort to address that problem. And so here the vehicle is aware of its environment and can detect pedestrians in the environment and alert the driver. But not only can it alert the driver, it can alert the pedestrian through their cell phone to a safety critical situation. And so this expands the typical vehicle-to-vehicle or vehicle-to-grid kinds of concepts to a vehicle-to-people or pedestrian kinds of concepts. A really interesting extension of that notion. This example was on smart water assets, and it was Qualcomm and CH2M Hill. And this team is using advanced communication and IT to help utilities save water, reduce wastewater overflows, improve public safety, and enhance customer service, including the ability to detect leaks, and not just the fact that there's a leak, but some information about the location of that leak, to manage water quality, effective distribution, and coupled to energy services as well. And it was Jason Ellis of Qualcomm who was the leader of this team. So an interesting water management example. Another project involving Qualcomm and a variety of participants, including Audi, focuses on smart roads and smart transportation. The smart roads effort uses advanced sensors and control systems to manage traffic flows as an effort to reduce congestion and travel time, increase safety, improve fuel efficiency, and reduce transportation costs. The team is, in this case, demonstrating a secure, reliable, and effective smart road implementation that is actually in place on the Interstate 15 highway corridor in San Diego, California. So they have an actual implementation strategy. A related team was using advanced smart vehicles to communicate not only for comfort and convenience, but for safety, crash avoidance, emergencies, and other critical functions. This was led by the U.S. Department of Transportation and was run in the Southeast Michigan region. They teamed up with Next Energy to create an electric vehicle application. It was based on an open, resilient vehicle communication platform that the Department of Transportation here has developed. And their long-term goal is to use this platform for applications that provide for traffic rerouting, smart parking, and a variety of other applications like smart traffic lights that recognize when there's a vehicle waiting in one direction, no vehicles coming in the other, and can respond to that situation to create more efficient traffic flows, reducing time for travel and fuel consumption at the same time. This is an example in the healthcare arena. This is a team that has grown remarkably over time. And the goal of this team is to transform a medical system focused on medical providers and medical systems to one that's focused more on individuals and patients and their care. It integrates home, primary care, hospital, assisted living, and pharmacy capabilities into a seamless personal care system for an improved quality of life. Projects led by Julian Goldman at Massachusetts General Hospital and by Mark Skubik of the University of Missouri. Other participants are the University of Pennsylvania, Vanderbilt, Worcester Polytechnic, Underwriters Laboratory, DocBox, the U.S. Department of Defense, Intel, Z-Wave Alliance, RTI International, PrismTech, Nanotech, Talend, Queralt, and Proactive Sense. So this is a very large, very interactive team creating highly integrated healthcare infrastructures focused on the patient. So you can see from this set of examples, this is only a few of the 24 that emerged, this challenge for voluntary participation to demonstrate the impact of integrated infrastructures on quality of life, on safety, and on efficiency turned up a remarkable number of examples and a lot of very strong technology innovation. So having these demonstrations, we want to move on to the next step, and we're calling the next step in this process the Global Cities Challenge. We want to launch this in September of 2014. So we're putting in place the infrastructure and getting ready for that launch. And the primary goal here is to move from the demonstration projects that were at the heart of the Smart America Challenge to deployment at scale. And another important feature is to move from what is a national effort to what we hope will be an international effort. And I'll talk about that more in a minute. But a central concept of this challenge is to create what I'll call action clusters. And these are teams of cities who are working, each working on a similar technology challenge. They might be working on smart building management, or they might be working on water management systems. But the cluster is a set of teams who are working on a common technology challenge. And the goal is to, by working together in clusters, to reduce the time and costs for smart cities deployment. So let me say a little bit about how this might work. So on the one hand, we have a wide variety of smart city projects going on around the world. In the U.S., participating in the Smart America Challenge were the cities of San Jose, Detroit, Austin, a number of others that are not listed here, like San Diego, California, also Washington, D.C., Montgomery County, and a variety of others. So we have a number of smart city projects going on in the U.S. You'll hear in a moment more from Gilly about some of the European efforts. Wide variety of really interesting and aggressive smart city projects for cities across Europe. Other cities in Asia, in Singapore, in Japan, South Korea, and others involved in smart city projects, and the list goes on with Australia, Africa, South America, and more. And so we have around the world a large number of cities who are in the planning and project phases for important smart city projects. On the other hand, as we were able to show in the Smart America Challenge, there are a large number of innovative technology folks out there today who are working on novel sensor systems, important strategies for cybersecurity, communications and networks, infrastructure projects, cloud services, utilities, robotics, and we'll hear more about building controls from Stephen here in a bit. So we have these two sets of efforts, and the idea is to bring these two kinds of organizations together in action clusters. And a cluster might be organized around, for example, coordinating energy management with air quality and traffic management. One of the Smart America projects is organized around that kind of activity. On the other hand, we might have cities who are focused on sustainable implementations and green technologies. Others with interest in emergency response and disaster resilience. Yet others on building design or energy systems. And the list goes on. All of you can think of more examples of this. And so around each of these technologies, we might bring together teams of cities from the U.S., Europe, Asia, South America, and elsewhere, who are all focusing on a set of common technologies and connect those cities and their efforts to technology innovators who have innovative technologies that can facilitate those efforts and help to meet the city goals. So that's what we'd like to do in global cities. So what's the motivation? Why should cities and innovators and governments participate in this effort? And here's some of I think, the benefits that can emerge from an effort like this. So for the communities, the cities, the regions, the nations, you can reduce the time and cost of smart deployments by connecting to innovators with efficient, low-cost technologies, and you can leverage your investments by working together with other cities who are investing in the same kinds of technologies. If you're an innovator, you can advance your technology effort and connect to customers by demonstrating that your solution works not in just one city or one application, but actually works across a range of different city implementations. Also gives you a chance to test your technologies at scale, and that's hard to do in a real implementation environment. But by working with cities, one could do scaled pilot deployments to demonstrate effectiveness and function. For governments, whether these are local, state, national, or regional governments, this is a way to promote smart city economic and social benefits. And a key issue here is rather than deploying solutions city by city, where two adjacent cities might implement a water management system that's different in each case. And so for when you walk up the chain from a city to a region or a state, cities across the state might not be interoperable. Yet in the global cities strategy, that interoperability, for example, for transportation management would extend from a city to a county, to a region, to a state, to a nation, for broad management capabilities. Part of the challenge also is to try to reduce deployment costs and to speed adoption of smart cities efforts. So in summary, this is an effort we'd like to launch on top of the earlier effort where we were able to identify innovators. We want to launch in September of 2014. This slide shows some contact information for the folks who are involved in launching that. And stay tuned. We'll be sharing information with the CIB task group about that launch process. And we hope that many of you will be able to join us. So with that, let me turn the desktop back over to Tom.
Yes, thank you, Chris. That was really nice presentation. Chris, do we have questions or?
Yes, Chris, thank you very much for your presentation. You gave a very nice overview of what is happening in the broad spectrum of topics related to smart cities in America, and the way you are pursuing further innovations and especially implementing them and making sure that upscaling and replication is taking place. Chris, maybe we have, I think we have just a couple of minutes for some questions, and I haven't yet received from the audience questions, but I do have two questions or remarks, Chris, if I may.
Yes, please.
The first is, I think what keeps us busy is the wide variety of applications and spectrum of smart city topics. And then relating that to the CIB community and where we are involved in, I would like to hear your opinion relating to especially cyber physical systems related to building technology. You showed some applications on distributed energy systems, emergency response, etc., including closed-loop healthcare. But how should the building and construction industry prepare on the fact that these cyber physical systems might be integrated in the building technology itself?
Yeah, very good. And I think Stephen will talk a bit about this as well. Commercial facilities and buildings are a major part of the energy landscape, as of course are residential facilities. In particular, in the commercial sector, there's really in the U.S. a very strong interest in using smart building controls, not only for energy conservation, which is a really important goal, but also for more efficient operations and for improved quality of life in the job setting. And so these kinds of systems include smart temperature and environmental control, but also sensing of activities and location to pre-position elevators to control lights and ventilation systems and so on. So smart buildings can provide a wide variety of benefits that range not just from energy conservation and water conservation, but also just quality of life and effectiveness and efficiency of interaction. We're also seeing in the U.S., particularly in the Southwest, the deployment of a large number of residential photovoltaic capabilities, and folks who are interested not just in consuming electricity, but using their capabilities for generation to provide electricity into the system and to reduce their costs as a result of that. And so designing home area networks and the capability for networking appliances and so on in building construction, residential building construction, is another important goal. So building construction is key to, I think, all of the goals of our smart cities efforts.
Okay, thank you. So, and this reflects also in a discussion in Europe, where the initiative you are involved in the U.S. Reminds me very strong of what the European Commission is aiming at with their Smart Cities and Communities initiative, where they have launched a European innovation platform on smart cities and communities, which also has the objective of speeding up and bringing towards the marketplace various smart cities initiatives across Europe in order to further enhance replication and scalability. However, one of the things I think where globally the interest could be pointed to is that where you speak of cyber-physical systems, standardization is one of the issues there. If you bring in so many various systems focusing on various aspects, but all having in common the cyber-physical nature of them. And I think that there are some activities now on standardization of smart city initiatives, but it is one of the obstacles we have envisioned during the meeting in Helsinki, and which is also on the agenda in Europe. How is the United States working on that?
Yeah, that you pointed out a really critical need. In many instances in the U.S., we're getting sort of city-by-city solutions which are not interoperable, and that's going to very much limit the kind of progress that can be made. But we think this is not just a national problem, rather it's global, and so not just cooperating across the U.S., but cooperating with Europe and with Asia on standards for smart cities implementations. It's going to be critical, not only to create interoperability, but to create a global marketplace for these technologies. And all of us have an interest in that. So I think the wise thing to do is for us to join forces across nations and work together in finding opportunities for developing standards that enable a wide range of technology solutions. The standards should be technology neutral, but should enable innovators and entrepreneurs everywhere to use those standards as a platform for common interoperable solutions. So we got to work together. I think there are good ways to do that. I think Europe and Asia in particular are strong leaders in the smart cities arena, and we hope through activities like Global Cities to create opportunities for collaboration on standards.
Great, I agree, and I think in the framework of the IEEE organization, for instance, but also regarding the U.S. and European government and Asian governments, we should join forces there. I think it's one of the critical aspects also for smart cities, and also in the framework of what we envisage as CIB, that has to be addressed in some sense, and cooperative efforts have to be made.
Very good.
So, can I ask for anybody, if there are any comments for these presentations, please send your messages in the chat box to me, so I can harvest them and use them for convening further this WebEx. I think Mimo and Gillian, we can proceed with your presentation, Gillian, and maybe Tom can host that.
Okay, hello. Good morning, everybody. Can you hear me?
Yes.
Okay, so I'm really just going to talk a bit about BRE's Future City programs and the sort of work that we're doing on that and the linkages that we're making within that program. So we started this journey really because we were looking at cities. We've been working for many years in the built environment, all aspects of the built environment, and typically looking at buildings themselves and the performance of buildings. But it's becoming increasingly evident that you can't disassociate buildings from their environment, and if we're going to achieve the efficiencies and improvements that we need to achieve, then we do need to look at the whole city and how it functions. So I think we're all pretty aware of the challenges. Population growth is still increasing, so projections are 8.3 billion by 2030, and much of this is going to actually move into cities. So we've now got more people living in cities than in urban areas, and the expectation is that that would increase to 80% of the global population will be in cities by 2050. Cities have got a disproportionate use of resources accordingly, so they've got 2% of the land mass, but they actually consume 80% of the resources. And this is an issue across the world, not just in Europe. And we're getting this, vast exponential growth in technology. So the estimates are there are now 3 trillion sensors embedded into the urban environment, and there are 50 billion web-enabled things by 2020. So there's lots of activity, and I think one of the issues is how is that going to be integrated and made efficient, and we've talked a lot about interoperability, and that's one of the key areas. So the question that was posed as part of this Future Cities programme was, how do we deliver and operate efficient cities of the future? And what is needed to support development of these smart cities? And through the work that we carried out initially in terms of reviewing what was currently happening and what needed to happen and where the gaps were, these are the sort of headline bullet points in terms of almost like the shopping list of what we needed, really. And it was coordinated, consistent policy objectives, because a lot of this will come from the top. The mayors and the policy makers are actually setting out how cities are managed, how they're developed, how they're regenerated. So there needs to be consistent policy objectives that guide that future growth and that future development. And then to support that, and I think, as Chris was saying, standards and codes of practice are critical, because we need to avoid having every city having a different way of doing things. So in order to enable that to happen, whilst also encouraging innovation, there needs to be some accepted standards and codes of practice that set out a standard approach for various things. And this includes the interoperability of systems. So without that standardisation, it's very unlikely that systems will be able to speak to each other and work efficiently. then I think also, as Chris was saying, having thought of a really good idea and shown that it's technically feasible, that now then needs to be demonstrated and validated at scale. So within the cities or within a region or within a nation or across nations, that has to happen. It has to move from the lab into the real world. And by doing that, and I think we're all aware that by doing that, you then come across all the various barriers to implementation that will then need to be looked at in more detail. More research will be required to deal with those. And another key area, and actually it's becoming more important, is this understanding of how communities and how people interact with their cities and how the physical environment affects the social environment. And I'll talk about it later, but a lot of our work now is moving towards that, the intersection of people and the built environment and city function, and how do you get this? It's almost like the triple bottom line in terms of getting the best out of that intersection. Development of innovations which span city subsystems. Again, this sort of comes back to interoperability and making sure that we're not dealing with things in silos. So thinking about, well, how do we sort out the water, but then we haven't thought that doesn't then connect through to how other resources are dealt with, such as waste or food systems. And then that leads us into the integrated supply chains for products and making sure that services are fit for purpose, they're doing what they need to do, and they're becoming as efficient as possible and as integrated with the other aspects of city services. So the programme started 2 years ago, and it's due to complete next year. So the scope is really looking at, obviously as you'd expect, we're looking at the built environment predominantly, but we're also looking at sustainable communities and resilience of those communities. And it's looking towards the future to say not only how do we improve cities, but actually how do we make sure cities are able to cope with issues of the future, so the resilience into the future. So one example is climate change. We know that we're going to start to get overheating in some parts of Europe. It's already starting, actually. And how do we make sure that our built environment, our cities, are able to cope with that into the future? Improved city operation, again, there's another driver for that is the restriction on public sector spending that we've got across Europe, across the world, really. And so cities have to perform better, but they've actually got less resources to have that improved operation. So the efficiencies that we can get through combining services and having better systems and improving the efficiency of resources and other aspects of the city environment is a way to achieve these improvements whilst working within the constraints of city budgets. And then lots of the work that I've seen is about new cities or new developments within cities, but actually most of the built environment in cities, in Europe in particular, is already here. So we need to have a significant focus on how do we regenerate parts of our cities and how do we regenerate our existing city infrastructure to bring in these improvements. And I think also, as we've already talked about, we can't just all be in our silos. We can't even be in the European silo. We do have to think internationally so that we can get the best out of the work that we're all doing. And we will, there will be new intellectual property will come out of this, which has got its own challenges, and new products and services. And I think that's part of the issue we need to look at is everybody's developing new things and new stuff. How do we make sure that they can work together? So we're very much looking at collaborations. We've got quite a big partnership at the moment. There are 70 partners in the overall program at the moment, and it's growing all the time. And part of the reason that I'm sharing with you today is that we're still looking for partners. It's not going to stop in May 2015. We want to continue and maintain and grow the program and work with other organisations to build upon the work within this program. And it's already leveraged in quite a lot of additional money through linked projects. So it's standing at about £30 million worth of collective project value at the moment. So I'm just going to talk a little bit about some of the projects that are going on at the moment, just to give you a flavour of what the programme is and the extent of the programme. And then later on I'm going to talk more specifically about the resource efficiency project. So just some of the projects we're doing. So energy supply and demand, as you would imagine, is one of the key areas. You know, you can't look at an efficient city without looking at energy optimisation, supply and demand. So we have been doing, there's quite a few of the projects related to that. So for example, energy optimisation. So, and it's quite similar to some of the things that Chris was talking about. You know, how do you make sure that you're optimising the grids and all the micro-generation that's going on within that city? So people are generating their own energy. You have quite often, particularly within Europe, you have quite an old and ageing infrastructure in terms of the grid system. So we do need to renew a lot of that infrastructure. So whilst we're doing that, we really do need to think about more sophisticated energy demand response systems. So we're doing some quite significant projects, BRE, along with Cardiff University, which are part of big European projects, to see, well, how do you have the systems in place to optimise that energy distribution, but including the energy that's being produced by people, on buildings, so microgeneration in particular. Linked to that, we've got a project looking at an imaging tool for future heat networks. So the UK has been quite lagging behind the rest of Northern Europe in terms of looking at heat networks, but we're starting to catch up. So we've got quite a significant programme going on in the UK at the moment that is working with many local authorities, so that when they're regenerating parts of their cities, they're now actively looking to include heat networks within those developments. And there's about 10 pilot projects, feasibility studies going on at the moment, and the heat mapping tool basically helps those local authorities identify whether or not a particular area is suitable for heat networks or not. So it provides a feasibility tool to make those decisions. Another project that's going on is obviously within the built environment. We're doing a lot of work on BIM, building information modelling. So how do you basically ramp up the information that's being collected at the building level to feed into the city level? So city information modelling, and how do you basically manage the information transfer between those two so that you can optimise the city performance and the building performance? Another project is looking at sensors, so sensors within buildings, not only in terms of managing the energy performance of the building, but also the structural performance of the building. And I think this is, particularly in areas where you do have issues in terms of structural issues with buildings. And this is really saying, well, what are the sensors that we need to make all these, to understand the buildings better in terms of how they're performing at all levels. Another project, there's several digital related projects, as you would expect. One's about digital infrastructure. So how do we embed the digital infrastructure that we're going to need in order to have these smart cities of the future into buildings now? Because if we're not thinking about it now, then it's going to be quite expensive to retrofit it all later. So trying to get some consistency in terms of the standards and the code of practice in terms of what is that infrastructure, and so this is linked in with a TSB, a Technology Strategy Board project called Smart Energy, and it's looking at I'm going to have to read this out because I'm not into digital, so I don't really understand a lot of this stuff. But it's the operation of a prototype open standard communication hub and a physically validated interoperability framework requirement specification. So, you know, it's basically getting to the point where we're looking to create these standards for interoperability, particularly within the built environment. And then another one that's very important, actually this is probably on a personal level, I think this is a really key area, is about cybersecurity. And I think many people that need to be convinced about the smart cities and whether it's going to work will have a concern about the security. So what happens if it all goes wrong? What happens if there's a virus? You know, how do you make sure that not only people's information is protected, but actually the systems that we all become extremely reliant upon are secure and can't be hacked into and damaged in some way. So we have a project looking at developing these cybersecurity schemes and standards across the board, so for the products, the systems and the networks within the buildings and the built infrastructure. So this is that's very much in the digital area. I'm going to talk about resource productivity later, and I'll give a bit more information about that. But if you look in the centre of the screen, there's something called the Healthy City Index, and we're getting a lot of interest in the Healthy Cities Index. And this is basically looking at how do you assess the health of a city, particularly in relation to the impact of the built environment on the health and well-being of the citizens, of the people that work in there. So because of the work that we've been doing with fuel poverty and the impact of fuel poverty, we started the ball rolling really with the Healthy Cities Index in terms of housing. So we've now been able we've developed a methodology so that you can basically go into any city and you can work out how healthy is the housing for the citizens. And this is quite important because one of the things we found talking to the city leaders is that they want to know how their performance is across a whole spectrum of issues. And so if they can see, okay, so London actually doesn't perform very well in the Healthy Cities Index for housing, and a lot of that is to do with the fact that we've got old housing, so there's contribution towards respiratory problems, there's not very good access in many cases, so we have above average incidence of falls and trips. So you can see the reason for it. Once you see that there is a city is performing better or worse compared to the norm, you can start to look in more detail in terms of what might be the underlying reasons. And in order to do these Healthy Cities indices, we do have quite a lot of data sets that we can use to support that. So as you can see on the screen here now, that we have data sets for pollution, we have data sets for deprivation, we have the transport network, so we know where the concentration of transport is, so the pollution that's likely to arise from that, and the noise and other issues associated with transport. And we also have quite sophisticated crime statistics, so we can start to use these data sets to actually get quite an accurate picture of how different cities perform in all manner of in all areas that relating to health and well-being. And increasingly important is the temperature charts, because we can now start to see, well, where we like to get overheating in the future, where's the water scarcity going to be. And all of those need to be combined, really, not only to understand the picture of where cities are now, but mainly to prioritise the actions for the future. So where do you need to put your resources to improve the city function? So some of the products that we're looking to get out of this programme, and I think this is probably important, particularly for collaboration with other parties. You know, we do see that there is a a real need for energy optimization tools in terms of real-time energy utilization, but also in terms of the district heating mapping, so that we can see very quickly and easily where it's going to be feasible. The standards and protocols for a safe and secure digital city systems are critical, and we're developing interoperability schemes for digital products. BRE, actually generally, we've done a lot of work in terms of real-time monitoring of buildings. Can we transfer some of that into the city environment, obviously linking into the monitoring of the buildings? I'm going to talk a bit about the resource management and the healthy cities indicators. We're already looking at housing, indoor air quality, crime, aging population, and we're starting now to work out how do you assess the health of a community. There's a very, very long list of partners here, but it's really just to show you the breadth of who needs to be involved with these sorts of projects, really, to make sure that the research is actually going to lead to something that's useful for those people within cities and city functions that are in a position to implement it. So you've got the obvious people like the government departments and the city councils. So we're working with many of the future city demonstrators in the UK. Public sector, as you would expect, the hospitals are quite keen to look at all the health and well-being issues and understand where they need to prioritise their investments into the future. But also the police, they're very much up to speed with how to use data to manage their resources, and they recognise that actually there's a lot more that they can do in that space once they can get access to the data in a usable form. Trade bodies, as you would expect, we have the industry planning consultants, contractors, the various software systems providers. So IBM are actually very much involved with the programme, but along with many other providers such as Siemens, we've got British Telecom are involved. Landlords, we have in the UK, we have many social landlords, so social housing is provided by registered social landlords, and they're very keen to make sure that the housing that they're providing is actually functioning within the city environment. So they see it as part of their asset management, and how do they make sure that they can grow their assets but have them perform in the best way within the cities that they sit in. As you would expect, utilities are very interested in this space, as are the product suppliers. And there are a whole raft of independent NGOs that are very concerned with future cities, and I think particularly the aging population. So many of the associations that are looking at the elderly are concerned with making sure that not only cities but also buildings are going to be fit for purpose for our aging populations, and that is a very key issue in Europe in particular. The professional bodies, and we also have a great deal of interest and involvement from universities and research institutions within the UK, but also outside the UK. So notably, we have in France CSTB, but also Stockholm are involved, and the University of Brasilia. And then further afield, we have WHO are very involved with the Healthy Cities indicators. So it's a very long list of partners, but I think to look at such a massive issue, a global issue, you do need to have a strong and large partnership to deal with it. So just one of the things that we've taken forward recently is a Centre for Resilience. So resilience. So we've come up with a definition of resilience, and this resilience and smart cities are interchangeable, really, because we're going to have to be able to withstand and recover from extreme events, and that includes weather, but also disasters, terrorism and cybercrime, and the increasing population and urbanisation, so the societal resilience. So the Centre for Resilience is really starting to pull that together, looking at the mitigation and adaptation that's going to be needed in the built environment to factor in that resilience, and starting to test, trial, demonstrate and certify the innovations that will come out of it. So we already have 70 organisations involved with that, and there is a conference in November, an inaugural conference to set it all up, basically. Hang on, I've got a message. Oh, okay, sorry. Okay, so I'm just going to finish up with an example of one of the projects, because I think it makes it a bit more interesting if you can talk about a specific project. So this is looking at city-scale resource productivity. So how do you look at the most efficient use of resources within a city? So from the economic perspective, the social and the environmental perspective. So in doing this project, we focused on a UK city. It's not really a city, it's a big town called Watford, which is the one that BRE is located in, and Brasilia. So we've been doing a series of workshops in Brasilia as we've been doing the project. The phase 1 project finishes this month, and the phase 2 project is now under development. So the basic concept is, you have raw materials, you have products coming into a city environment, and then you have a large waste management issue to deal with the waste arising from use of those products and materials. So how do you capture as much of that as possible of those waste materials back into the economic loop within the city environment? So that is basically the objective of the project. So we looked at the UK versus Brazil, and actually there's a lot of similarity in terms of things like poverty. We have 17% fuel poverty, but obviously in Brazil you have 21% below the poverty line. 90% of the population are in cities in the UK, and 81% in Brazil. Population density is much higher in the UK, as you would expect, because we're a very small country. And interestingly, they've got more mobile phones in Brazil per 100 citizens than in the UK. So the global statistics for waste, one of the very key statistics for waste management is actually about half the world's population don't have a waste collection for their municipal waste. So that's half the world doesn't get its waste collected. So obviously that has a major impact. And in fact, the impact of the waste globally, of the 4 billion tonnes of waste produced globally, is about 1 billion tonnes of CO2 equivalent. One of the facts that never changes is that as a country becomes improves economically, the amount of waste increases as well per person. So if you follow that link, then actually the estimated impact of waste in terms of CO2 equivalent is going to be 3 billion tonnes. So it will triple by 2030 if we don't work out a way to manage those materials more efficiently and in a better way. Cities actually can't, they find it it's one of those services that particularly rapidly developing cities really struggle with in terms of managing waste within their area. And this is largely because there's a huge infrastructure gap now, and it's actually increasing. So it's estimated that by 2025 there'll be a $150 billion spending gap per year in terms of the infrastructure that is required to manage waste and the infrastructure that is in place. So it's a key area for many of the city leaders. How do we deal with it? And actually, it's one of those areas where if you do deal with it in a better way, then it has all kinds of benefits for the city and for the citizens within those cities. We're finding that many of the people that are employed in the sector, at least half of them are actually employed informally, and this is not a good thing, because there is no health and safety or well-being issues being addressed within that employment. I don't consider that to be a sustainable employment. If people on landfill sites picking out rubbish to recycle is not a sustainable employment as in our books. Global recycling is very low, it's 20%, incineration is less than 10%, and everything else goes to landfill, and in developing countries mostly goes to open dumps. So there's a lot that can be done to improve that situation. And by improving it, you create jobs and you improve the welfare of the workers. You massively reduce the impact of waste, not only on the local environment, but also on the wider environment. And you create energy for cities and feedstock for products. So it's a resource. It should be seen very much as a resource rather than a waste. And once that happens, the local economy can improve quite dramatically through the investments, the reduced costs, and also the ability to have this sustainable and secure feedstock for industry. Because one of the things that we're seeing, so you see one of the pictures up there is for tantalum. So we have resource security issues for many materials now. So it makes no sense to just go and chuck away materials into landfill sites rather than harvesting them and keeping them in the economic loop. But it's not a simple thing to do, and we do need to have urban planning and investment. There does need to be training, education, codes and standards. There needs to be many different types of interventions, financially, but also legislation, as we found in Europe. And actually, a lot of the work that's happened in Europe is very useful and can be applied in other countries. And, for example, when I was in Brazil, it was very interesting to look at their waste management regulations. And they're almost a direct recycling of the European legislation. They've taken it and they thought, actually, this will work here. So they've they've transposed it into Brazil, large amounts of it. The problem is that they're not enforcing it, so nobody's taking any notice of it. So that's a bit of a, it's all very well to have great legislation, but you have to enforce it. So the basic methodology that we've come up with is to map the sectors. So what is the resource? How do you find out what resources are available within a city? And that's a large mapping exercise for the different types of waste streams, so the municipal, commercial, industrial, construction, and stockpiles. I mean, stockpiles are an interesting one because actually you can see that there are huge stockpiles of materials in these open dumps that could be processed to create resources. Then what are they? What are these resource streams? What are the material streams in terms of the quantity and the quality? How are they currently being managed and where are they being managed? And what's the economic and legislative framework that's supporting those management routes? And how much is it costing? Because actually, if you're going outside the Europe, you're very much left with and into places where enforcement is low. So anywhere where you don't have enforcement of waste management legislation, the only incentive you're left with is a financial incentive. So it's very important to understand what are the costs versus the benefits of different management routes. And again, without enforcement, it's also difficult to see how you would have things like landfill tax and renewables incentives, because if the enforcement isn't there, then it's going to just go via the illegal or the informal routes, and then all these other complicated financial systems won't work. So it's very important to have that as a baseline. But what we're doing is we're working out what the benefits. If you implemented changes, what would be the benefits at a social level, an economic level, and an environmental level. And this is very important for planners and for city leaders. They can understand that they can make significant improvements on all three levels by making some changes to the way in which resources are handled within their city. And we're starting to see it. So we're at the process where we've got some examples, and we're going to take that forward in Brazil in the next few months. So are there any questions? Do I need to?
Thank you, Gillian. Thank you for your presentation. It really is a broad scope, and you presented a broad broad range of initiatives BRE is involved in and UK is involved in. I'm just wondering, maybe one question just to put it in place. I think one of the interesting things is that you brought up the waste and resources aspect in cities, and what we see there, of course, is a large stock, not only of household waste, but the stock of the built environment itself, having lots of materials in it. And one of the true things you have mentioned is that if we think about smart cities, we have to think about how to turn existing cities basically into smart cities. There will be in the world a large chunk of renewing activities, but there is also a large stock of already existing buildings and built environment. I think it is one of the key issues to come up with innovations in order to transform this built environment into something which is fit for purpose for the next 50 years, not only with respect to energy, but also with respect to living conditions, of course. And there I would like to make a link with Chris's presentation, which is so much draws so much the attention to cyber-physical systems. There is an opportunity now in the event of transitioning to a more sustainable energy system in the built environment to introduce new concepts of regeneration, where also cyber-physical systems are involved into the new building concepts. And I think that is one of the broad and interesting aspects on the horizon there. So, Gillian, thank you very much for your presentation there. I would like to draw the attention again that there are opportunities to send me any comments in the chat box. Maybe, Tom, you can once again tell everybody how to do that also during the presentation. I think you have to touch with your cursor the uppermost tab, green tab, which pops up then and gives you the opportunity to click on a chat box where you can send in your chat comments.
Okay, Chris, this is Tom. I will do so.
Okay. So then, continuing, just a further remark, Gillian. Is there any roadmap in the UK focusing on transitioning the built environment in relation to the energy? Sustainable energy demand in the next decades?
I'm not aware of a roadmap to speak of. I mean, there are one of the issues we've had actually. I was talking to my colleague who manages the Future Cities programme, and one of the issues is that there's so much work going on in terms of energy optimization, energy systems within cities. It's just very difficult to actually to work out exactly where any work you're doing, where does that fit within the context of all this other work that's going on. I think as you go into the European context, it becomes a very, very crowded place. So I mean, I'm not sure how they're going to achieve this. I mean, one of the areas that maybe it could be coordinated is through the utility companies, because we do get, for example, at least half of our utility companies are French companies. So there is sort of a European context for provision of energy. So maybe it's best for them to come up with a coordinated approach, and then researchers feed into that, because I can't see otherwise how you would necessarily get it unless the policymakers at the UK and the European level decided that they were going to do something.
Okay. I think, Mimo, we have to proceed further and invite Professor Stefan Kendall to do his presentation on open building and implementation in smart cities. Gideon, thanks again for your contribution.
So is it my turn now?
Yes, it is. It is. Please share your desktop. Great.
There we go. Okay. Is my screen visible now?
Yes,
it is.
Okay. Well, I've been very interested to hear the presentations thus far. I've tried to do a little bit of study about smart building principles, and the presentations that were offered today really help fill in some gaps. The agenda is obviously quite broad and ambitious. My comments will be rather short. I had no idea how much to prepare or how much depth to go into. So what I'll show you in a few slides sketches a perspective that is shared by the Open Building Commission members. We've been a commission now for about 18 years. We have members all over the world who basically share a set of principles that I'll explain to you, and hopefully there'll be a way to show a link with the principles that are espoused in the smart buildings discourse. So, am I being heard okay so far?
Yes, it's loud and clear.
Okay. Well, I'm on slide 2. Is that what everybody is seeing?
Indeed.
Okay. Well, it's rather a truism to say that cities are never finished. We build, we change, we adapt, we tear down, we rebuild, and it's a very messy, extremely messy process that all of us in our one way or the other are trying to make sense of. The sustainability agenda, of course, is part of this discussion. How do we do things that are sustainable and long-lasting? But, of course, we all know that everything won't last forever, and we change things. So we have to think beyond technical solutions because technology, as I think someone said before, is just part of the equation. We have social structures, we have political structures, we have decision-making, and so I'm going to try to make a link here with what I've heard from the Smart Cities presentations and the open building perspective. From what I've understood, Smart Cities emphasize flows of physical and social capital. As Chris said, there's the cyber-physical systems that are at work. All of these complex, non-homogeneous systems involve complex networks of communication and hopefully pay attention to everyday citizens in the co-creation of quality and environment. And, of course, open building itself shares this understanding of physical and social capital. And I think our contribution may be in the introduction of the idea of a hierarchical level of intervention. So what does that mean? Well, it means that as our cities continue to change, we find that there's a need to balance things that change quickly and things that don't change so fast. What can and should be permanent and what can and should be changing. this picture of the Ise Shrine is, I always use it in lectures because it's renewed every 20 years and has for 1,000 years. And it's an example of rituals of renewal that are deeply embedded, for example, in Japanese culture. But we renew everything all the time, and making sense of that to make smart cities is a key issue. So not only do physical systems change, but the decision-making about physical systems tends to be rather complex. So we generally say that the shared decisions, the decisions that take a long time to make and that have a long lifetime, are generally political in nature. They're either dictated by somebody, by some level of government, or by some corporate mandate, or they're democratically established, but they are shared in essential terms. On the other side of the decision-making story is the individual interests that are tending to be short-term, that change more quickly, and therefore, how do we balance those two worlds of decision-making? So that means that inevitably, I believe, and I think observation of city changes over long periods of time reveal this, the city structure tends to be permanent to the urban fabric. The urban fabric is permanent to the buildings. The building is permanent to what goes in the buildings, and what goes in the buildings is permanent to the equipment that we deploy to make buildings occupiable. And I think it's not a surprise to say that this hierarchical structure, when it's recognized and instantiated in planning and in decision-making, will help us manage communication up and down that hierarchy and helps reduce friction when change takes place. So, for example, the city infrastructure, that means the main highways and utility systems and waterways and so on, those tend to last for a very long time. But then within that, we have the urban fabric with its own infrastructure, its own streets, its own urban patterns, and that tends to be permanent to buildings, which come and go at a much more rapid clip. But once you have a building, it is permanent to what we call the fit-out. The buildings you see on the right in Chicago are there for a relatively long period, maybe 50, 75, or 100 years, but we all know that the tenants change and bring in their new equipment and their new partitions and their new computers and new lighting systems and so on. And then within that, we have computers that change and so on. So there is a hierarchy of in the built environment, and it tends to relate to certain decision-making levels as well. As this general model on slide 7 attempts to show. At the left, we have more collective entities and more collective physical systems, and on the right, we have more individual decisions and more personal environments. And these levels are actually evident internationally and have shown themselves to be evident over history. So this idea of levels of intervention helps organize decision-making towards greater effectiveness. There's evidence to that, and I'll explain more if I have time or if there's interest. But what is important to say is that these levels have very difficult, sometimes, dependency relations between them. For example, those operating on the urban infrastructure level do in fact dominate decisions on the urban fabric level, just like the architect and landlord of a base building do in fact dominate what the tenants can do, what they can bring in, and how they can deal with their own space. So there is a dominance relationship from the top down and a dependency relationship from the bottom up, and these communication links have to do not only with decision making, but with the operation of physical systems. Ultimately, I believe that you would all agree that society benefits when everyday environment is healthy and alive, when its energy performance can be organized on levels right down to the home. So what matters is that we think that design and planning are always struggling to deal with the time dimension. Second, the change and permanence are realities that must be recognized in our decision making, in our physical systems planning, in our development of infrastructure. Third, that levels of intervention can be helpful in structuring decision making from the national level to the dwelling level. And then fourth, that distribution of control rather than centralization of control can be troubling, but it is a good thing if managed in a smart way. I always struggle with the word integration because it smacks of dictatorial, centralized control, and I think the reality is that we know that decision-making is highly disaggregated, and that often makes for a healthy situation. So we do find in many different countries evidence that clients are organizing their decision-making around this wonderful diagram, which was developed by the Canton Bern, Switzerland Office of Properties and Buildings. It's an acquisition method that now is used to procure all of their public facilities. They see the primary system as a 100-year investment that is long-term and relatively unchangeable. They see the secondary system of their physical real estate assets as having a shorter life cycle, and the tertiary system, as they call it, is a very short cycle investment. And it's interesting that model, the crate, the bottles, and the liquid, is an exact overlay with the way American, Japanese, Chinese, European office building procurement processes are organized. So it's nothing new, but we find that it's very helpful to explain it. So an open building and smart cities viewpoint entails a number of shifts of perspective. Architects always, of course, like to build monuments, but we need to think about everyday places, the ordinary environment. We need to think not static form, but dynamic form. Static systems are no longer what we face, but we face dynamic cyber-physical systems in very complex, non-homogeneous artifacts like cities. We need to quit driving our decision-making on the basis of suspected function, but rather for capacity for changing function. And then we need to think not what is special, but what is shared, and we need to move from this notion of unified, centralized design to distributed design. So, in conclusion, the questions really that matter are not technical, but they're concerned with smart decision-making methods that correspond to the realities of how cities transform. So those are my comments, and I'll just give you a few examples of how this perspective is finding traction in the real world. In Japan, the national government recently passed legislation providing incentives for developers to build 200-year housing. That's a major public decision that is a result of decades of what the Japanese called scrap and build, which meant that the industries were fueled by the continual construction of new buildings and then their almost immediate demolition when they found that they were no longer optimal. Functions had changed, technology had changed, but the buildings were designed for as quick fixes. So they rejected the scrap and build philosophy and are now operating in a stock maintenance approach, which is exemplified by this law that encourages 200-year housing. Another example is I just finished a consulting contract with a team of people for the Department of Defense Health Agency in the U.S. They asked us to recommend criteria and performance measures to assure that the architects and engineers they hire can deliver flexible buildings. That means that the asset life is extended because the buildings are planned for change. And there are examples in Europe and South Africa and others who are operating out of these concepts that I've explained to you. So thanks for your attention, and I'll be happy to answer any questions.
Thank you, Stefan, for your presentation. I think we have seen three presentations which gave a good overview of the scope of all aspects related to smart cities, from the cyber-physical system aspect to the environmental aspect, and now you are addressing, I would say, the planning and societal aspects of the built environment there very succinctly. I think we have Gillian has one remark or question to you, and that is, how do we get long-term smart decision-making at the city level when decision makers change every 5 years or so? Could you comment on that?
Well, that's a very good question. There may be no easy answer. I think the example I gave you in Japan is an indication of how one society, anyway, has found that deep social consensus exists in such a way that even with changing politicians and changing administrators and changing corporate executives, the society has come to a consensus that trumps the changing and kind of fickle attitudes towards politics. So I do think that we're talking about a deeply cultural question that without which we can't answer your question very well.
Well, I can add to that as an example, in the Netherlands, we have had a boom in office buildings in the last 20 years or so. And now, with the economic tide having been turned over, lots of those spaces are now not used, and it's a wasted capital in some sense. Where there are, at the same time, serious issues related to housing of elderly, having cheap housing available, social housing, and also in relation to, as I might connect to Gillian's presentation, aspects related to resource efficiency within the built environment, making possible more creative use of these office spaces, for instance, in the sense of greenhouses or locations where food can be grown.
Well,
so
just a comment on that. I'm sure you know Carl Decker. He's one of our open building group, and he's just recently finished a comprehensive analysis for several Dutch government ministries on exactly that problem. So that's one of the issues. Designing buildings for certain functions is very short-sighted, and that's why we need to design buildings that have capacity for changing functions. for changing energy requirements, for upgradability, and so on. And that's a paradigm shift that is going to have to be driven from the client side, but then the service providers have to learn how to perform properly with those requirements. So it's a multifaceted problem.
Exactly. I would like to add one additional aspect, and that is that in the built environment, changes taking place on a scale which makes sense also have impact on value change. If you take into account value chains, you can see that, for instance, in the energy regarding the energy aspect. For instance, in the Netherlands, there is now a trend that the landlords not only sell the house as a living place, but also the needed energy for it for the next 20 or 30 years, which can be transferred into a loan and to the landlords themselves. And then there will be a shift in the value chain from the energy companies and utility companies delivering the energy directly to the house owner towards the landlords themselves, making the houses more energy efficient and creating value by developing local sustainable energy systems, and in a sense being the owner of a house, including the energy production system, which makes it necessary to deliver the energy to the people living in the houses. So there is a shift from the energy companies delivering the energy towards the landlords, guaranteeing energy for the people living in the houses for the next 20 or 30 years. And these are shifts which are interesting to see and to take into account when we further, I would say, discuss any roadmaps regarding smart cities, because I think what we have seen today in your presentations, which were very clear and clarifying, that the ideas around smart cities are broad. It covers many themes, but there are certain aspects which are general with regards to the aspects of these cyber-physical systems, which are so important in order to make surfaces more compliant to modern-day and future technology, distributed systems, where we will see that standards are an important aspect in the role in when we would like to see an upscaling or replication towards new value change in the built environment with new players delivering services which are more amenable to change and to the end users' demands. I don't know whether we have further any time. Mimo, I give also a little bit to you for concluding these sessions. I think it was very clarifying for every attendee and all attending this session. We had planned till 12:30. It's now 12:39, so I would say it was a good WebEx, and one of the steps needed to further develop the roadmap and our vision for the CIB community, which will further be shaped in September during the meeting in Washington, back to back with the Eco District meeting, for which Chris Greer cordially invited us to have it take place there. Mimo, would you like to say something further?
Well, thank you, Chris. I mean, I think you concluded excellently the idea of. I mean, I think we had really nice 3 presentations, and it really gave us new viewpoints for the roadmap. So I think this was really useful for the our future work. So thank you all presenters for the good work. And as you, Chris, mentioned, so we are now then working towards the next workshop in September, which is kindly hosted by NIST. So and certainly this is really good feedback for that workshop as well. So thank you all once more about the presentations and for the attendees for this workshop. So yeah,
thank you.
I think we can now close the meeting. Thank you. Thanks a lot.